Okay, so let's quickly summarize what we already did. So here is basically some advantage of decision trees. It's obviously very easy and very easy to understand. It's very easy to interpret. So you actually can come up with a bunch of rules. It can handle both numerical and categorical data, right? So today we're going to talk about both at the same time as well. It doesn't require, requires very little preparation. In fact, in later on 593, so when we talk about this on decision trees, you don't actually need to do much data pre-processing. In particular, you don't actually need to do the rescaling because, only thing that matters is, threshold. You just need to change and find your threshold. You don't need to rescale your data in decision trees. So this is quite interesting. So you don't need to do, no need like and standardization or normalization. It doesn't matter because all you need is like some threshold to separate data into like different branches. It is also a white box model, so that means it can, and I'm exactly how I'm being trained and how they make the predictions. It's also can validate a model with a bunch of statistical tests if you need it. It's very much mirrored the human decisions and closely other than other approaches. So that's why a lot of scientific science and engineering field, they like using and they like to use decision tree algorithms. Okay, so the issue is ID3, it only accepts categorical and discrete features only. So it also have one of the biggest problem is overfitting. I also demonstrate that. So that means I only, perturb the data a little bit. That turns out my decision tree is completely different. And also this ID3 can only work with the classification. If your target is continuous variables, it cannot handle with and regressions. So then what I'm going to do is I'm going to introduce something a little bit more. So this will be like successor to ID3. It's called C4.5. It has a bunch of improvement from ID3. It has three parts. The first part, it can accept the continuous features by introducing thresholding mode. And we are not going to talk about this in detail today, but just let you know, C4.5 can accept and continuous features. It can also solve this overfitting problem by doing some pruning if you need it. It can handle this incomplete data with the missing feature values. So basically, there's a lot of practical issues. This and the C4.5 can be solved and it can be considered. But it actually, there's another thing for C4.5. It can solve a very good and very important part. That is, if we just using information gain, it will always favor the feature with a large number of distinct values. So that means if one feature has a lot of unique values, information gain will favor to that. So for example, suppose if you want to build a decision tree for some data describing the customers of a business, if you just use the information gain, it will decide which features are the most relevant because it's most relevant, it will put on the root of the trees. But for example, if one input will be the credit card numbers, it turns out this feature has a very high information gain because it will uniquely identify each customers. So that means there's no, basically there's no randomness. Once you have your credit card and you can have a one-to-one match one person. But in fact, we don't want to include that on the decision trees. Why? Because if you are just treat a customer based on a credit card number, you cannot generalize to the customer you haven't seen before. So this is a typical overfitting problems. So you just basically memorize or identify each and customer by using credit card numbers. But if I'm giving you a new credit card number or new customers, then there's no way that you can do any kind of predictions. So there's no way that you can generalize your models to new customers. So that means if I have a new customers, there's no way that you can make predictions. This is clearly an overfitting problem. So that's why I'm saying ID3 is a problem that has an overfitting issues. So what's C4.5? So this is basically a very important thing. It's the overfitting issue, because that will be and significantly deteriorate the and the performances of the ID3. All right, so and also so in like C4.5, what you do is instead of you choose the highest information gain, you choose the highest information gain ratio. That means from among the features whose information gain is average or higher. So basically, for those features whose information gain is above average, you are going to choose with the highest information gain ratios. You are not choosing the feature with the highest information gain. You are not choosing the features with the highest information gain ratios. You are choosing the features among those features. Information gain is average or higher. Then you choose, and among them, you're going to choose the highest information gain ratios. This things is just to trying to like penalize the features with large number of distinct values while not giving unfair advantage to very low information values. So that means it has two steps. The first step is we need to identify the amount of features that we need to choose from. So these will be information gain is average or above. Among that, I'm going to choose the highest information gain ratio. So what is information gain ratio here? So this is being defined right here. I want to record this is your information gain. And also this is being defined as like we go through all possible f values, equal to f. So this is basically we weighted this and with the ratios accordingly of this HSF, which is corresponding entropies conditional on my f value is equal to little f. So then and also so we can, but in the meantime we can define the entropy just on the feature of f as well. So we can just do the basically and the like minus sum of f log the probability f equal to little f times log 2 probability f equal to f. Right, so you sum all possible of that. So this is being calculated as right here. So this is basically the entropy on the feature f, which is also called intrinsic values. So this has nothing to do with the target. It's just being the entropy for the feature f itself. So the information gain ratio here is the ratio between the information gain and its entropy of the feature f. So this is information gain SF divided by the entropy of f. If your feature has a large distinct values, so that means this HF will be really, really large. Then as a result, the information gain ratio will be small. So in this way, if we want to find out the highest information gain ratios, in some way we are penalize the situation that that information the features has large distinctive or unique values. So these situations will be penalized. Okay, so let's actually implement this from scratch. Right. Okay, so okay, here we go. So right here, so okay. So this is we're using the entropy here, entropy feature, the same thing. This is your information gain. We have the same data here. But the difference is I'm going to add one more function, which is and we need to calculate this information gain. That means we need to find out, we need to find out that this HF, which is basically calculate the information and entropy for the feature of F. So this is basically the same function for the entropy functions if you look closely, but just work on the feature of F. So at the end, I'm going to and report the ratio. So this is IGI, which is information gain of I and ith feature divided by the entropy of features of ith entropy of the features. So this is basically we are getting the information gain ratios directly. So that's how we calculate this out. And this is my C4.5 right here. In terms of this C4.5, we need to find the features with the highest information gain ratio among the feature whose information gain is above our average. So the first thing that we need to do is we get this information gain and we get information gain ratios. The first thing that, and the second thing that we do is to calculate the mean of the information gain. Then we are going, on the first round, that we are going to find the index that information gain is above or equal to the average, right? So this is important to find the right index. Then among those index, I'm going to find the information gain ratio to be the maximized and to be the maximal one. So basically, so there are two steps. The first step is to find the corresponding features. Information gain is average or higher. The second is among those features, find the highest information gain ratio. So these are the round 1 and round 2. And I would say it's like step 1 and a step 2. Step 1 and a step 2. Okay, so if you run this, okay, so this is a new okay, so this is a new one. So like new function, that means I get subtable and a table, but with that node. So basically, I might say I want to get the debt with high. So basically, I want to get the subtable, but I remove the column of the debt. Just so we have the and the remaining 3 and features and the target right here. Okay, so then this will be my generic functions of the build my tree using the C4.5 algorithm. So the first thing that we're going to do is we're going to, and of course, get the target and features. If the tree, so like if we, if we, and we'll talk about this a little bit later, but if we still have, okay, so if we, and the first things, so if we want to build a decision trees, we're going to call the C4.5 right here. to find the corresponding, the best node accordingly. Then we are going to get these distinct values of the variables here. If this tree is empty, we don't have this tree, then we're going to create these trees. Then we're going to make this loop to construct these trees again and recursively, like what we already did before. But the difference is if we loop through all the features, then we still find and we don't get a perfect end result. And what we do is we are just going to take the majority rules and using this majority rules and to assign the leaf of the node. And to assign the leaf by this like a majority rules of the target values. So this is basically the situations. So that means if you like run into this part, then you will have a training errors because and after you go through all possible situations and all the features, there's still no way that you can separate and the plus and the minus, then you will end with have some training errors. So and by the end of the day, you just taking the majority rules to make the predictions. But everything else is basically the same. So the only thing that is being changed is instead of using ID3, we're using C4.5 to get optimal features from these functions. But once we get these optimal features, we're going to remove the whole columns to make sure we are not going to be and to make sure we are not using the same feature again. Okay, so if we using C4.5, you'll find out this is give you like basically exact the same trees that we already had before. Just because this data set is so tiny, it doesn't have this problem that we have a large, unique, distinct values for certain features. So just for this specific data set, C4.5 and ID3 give you exact the same decision trees. But that doesn't mean these two algorithms will always give you the same trees. It's totally possible in much larger data set that these two will give you completely different trees. But that's totally understandable for this tiny trees for now. But overall, this C4.5 is still using the information about the information gain, but with a different metric. It's different from and slightly different from ID3. Okay, so that's everything for the C4.5.